13. So after we finish this one, we are going to be verifying trig identities after we finish our, we did 4 examples yesterday in here?
5.
No, I think we only did 4.
We did 4, yes.
Okay. So we have one more to do.
Because number 4 we did
number 4 we did both ways, right? Yeah. All right. Verifying trig identities. All right. So as a reminder, you have your reciprocal identities, your quotient identities. We have our even odd. Honestly, our even odd, you are only going to be tested on the quiz. You're not really going to use the even odd identity in what we're doing right now. And then your Pythagorean Alright, I love tangerine sequence, I love cottage cheese, and then cosine squared plus sine squared equals 1. I need you to note that all of these must be squared to use them. So if you have 1 plus tangent of theta, that is not secant. It only works if it's squared. Does that make sense? Alright, so example 5 is going to be a fun one. Oh, I hope we have enough room. It is going to be the sine of x times the cosine of x over 1 minus the sine of x minus 1 plus the sine of x over the cosine of x. And I want you to simplify this. As you're writing all this down, I want you to note all we have are sines and cosines, right? So I don't need to turn anything into sine or cosine, right? So what do I do?
Cancel the cosine.
Okay, so I think your algebra 2 teacher would call that something like killing kittens. Because there's a minus sign in between them.
Positive mistake.
Yeah. It's an honest mistake. Yes, you can do that if you are multiplying. You can cancel them. But when there's a minus in between, we cannot cancel them. So, any other ideas? Common denominator is the answer. We are going to, and I'm going to kind of write over here what we're doing each time. Denom. So, what would I have to do to this one to get a common denominator? I'm going to multiply the top and the bottom times cosine x. And this one? Times 1 minus sine of x. You need an equal sign out front or I'll be counting off. That is going to give me the cosine of x times 1 minus sine of x. What am I going to get up top right here? I'm going to get sine of x cosine squared x. And what about here? It is a difference of 2 squares. A dot. Do y'all remember that? And what happens when you have a difference of 2 squares? I'm sorry, it produces a difference of 2 squares. So what will it give me? And I'm going to put a parentheses around this because it's minus. It's going to give me 1 minus sine squared of x. What questions can I answer? Are we okay with what I did so far? Does it make sense mathematically?
Yes.
Well, what do I know about 1 minus sine squared of x? I'm going to put a star next to it because that lets me know I just used a what? Pythagorean identity. So this is going to equal sine of x cosine squared x minus, what's that going to turn into? What's 1 minus sine squared x? Cosine squared x. I'm going to move down here. What can I do next? Can't cancel anything out. GCF. What do both of them share?
Cosine squared x.
I can factor out a cosine squared x. Good job. And if I factor out a cosine squared x, what am I left with up top?
Sine x minus 1.
Can y'all see that blue? Is that okay? And then I can cancel out this cosine, and this will leave me with how many up top?
Cosine.
Just one cosine up top. And then what do you notice about in my parentheses?
Factor out negative 1.
Yeah, do you agree that this is just the opposite signs of this?
Yeah.
So can I factor out a negative 1? So that's going to give me negative cosine x. 1 minus sine of x over 1 minus sine of x. Does that make sense what I did from here to here? And if it doesn't, you might just want to write it, like draw an arrow for you, that we factored out a negative. Just to let yourself know, like, hey, this is what I did. Now, what did you say? That cancels out, and what am I left with? Negative cosine x. Do I have any questions about any step? Do you need me to explain anything? Yes.
Can you explain how the 1 minus sine squared x became cosine squared x?
Yeah, absolutely. So right here, 1 minus sine squared x. If you look at our Pythagorean identities, if I were to move this to the other side, I would subtract sine squared x by both sides, and then I get 1 minus sine squared x. What does that equal? Does that make sense? Correct. What else can I answer? Anything else? Alright, I want you to flip over to the next page, and we already wrote it in our table of contents, but we are now going to do page 13, and that is verifying. Verifying trig identities is the same thing that we just did. The difference between simplifying and verifying is that with verifying, I am giving you the answer. You're welcome.
We're showing how it's true.
I am showing you, hey, here's the answer, prove it. You're not going to do anything different than what we just did. You are going to show me step by step how this goes. The only difference is you know where you're going. That can be a good or a bad thing. Usually it's good. But if you make a mistake, what happens if you don't end up at this answer? Then it becomes a little bit of a headache. Okay? I do want to let you know, this right side, whatever it equals, you are never going to change the right side. We are not multiplying both sides. We're not doing any of that. Whatever is on the right side is going to stay the whole way down. The other difference is verifying. I'm going to keep it in 2 columns. Whereas, did y'all notice how like over here, I just kind of like equaled and went through horizontally? With verifying, I'm going to be doing this vertically going down. Okay? So, what can I do first here? Yes?
Will there be any questions where it'd be like, the right side's wrong and you have to find it out?
Absolutely not. If that's the case, then the problem's wrong. Yeah. The right side will always lead you to the answer. And sometimes it won't even be like the most simple answer. You just need to make sure they match up. Okay? So what can I do? Change them both. Cosecant is 1 over sine of theta. Tangent is sine theta over cosine theta. And then the sines cancel, and I'm left with. And so people are like, Miss Olivares, I'm done. You are not. What is 1 over cosine of theta? You have to state that secant theta equals secant theta, therefore it is true. And now I have verified that that top equation equals secant theta.
Can you add on to like it's 1 cosine theta equals secant theta? Can you add on?
Nope, I want it all vertical. Yep, I want it all vertical. Your last line should always be it equals itself. Okay? What other questions can I answer? We okay? You have a question? Okay. Let's do example 2. Can I just cancel these? No. Oh, I didn't give you an equals. There you go. Sorry. What can I do? I cannot cancel them, so then what? I got cheese. I got cheese squared x minus 1. What does cheese go with? Cottage, cheese. And let me just prove it to you again. Right here. Cheese squared theta minus, not cheese, cosecant squared theta minus 1. What does it equal? Cotangent squared theta. Because we don't love cottage cheese, but we love cottage cheese. You can remember I love cottage cheese. I don't love, but just pretend. If you see CSC cheese minus 1, that goes with cottage, cotangent. Or you could say I love cottage Costco.
CSC, your teeth are always showing. And when your teeth are showing, you say cheese.
Okay. So what I just starred, that equals cotangent squared of x. Cotangent squared x. Y'all agree with that? Now what? Cotangent is cosine squared x over sine squared x divided by, what's cosecant? 1 over sine squared x. Again, we're not changing the right side at all. We don't touch it. We don't multiply. We just leave it. I can keep, change, flip. So I'm going to keep the top cosine squared x over sine squared x. Change that middle bar, let me move on up, to multiplication. And then flip the bottom to be sine squared x over 1. What happens? And what am I left with? Therefore, I got it. What questions can I answer? You do not have to write down what I'm about to do, but I just want to show you. I could have also said, hey, I can separate my denominator. And what is that divided by that? 1. What is 1 over cosecant squared x?
Cosine squared x.
No, cosecant goes with.
Cosine squared x.
And what is 1 minus sine squared x? And that's another way to do this in less steps. Yeah, if you want to write it down, you can. You want me to write it down right next to it? So the other thing I could have done was separated them. I separated this denominator between the two. So then that cancels, and I'm left with 1 minus, which is a Pythagorean triple of so that's just another way to do this. Again, as long as your math makes sense every step that you go, it can be a couple different ways, right? So you don't have to write that down. I was just writing that down to show another way to do this. Do you have a question for me over there? Like this? Or like this? Yeah. The next problem. Ava, can I go up a little bit or not yet? Are you sure? Okay. How far up? Like all the way? Or no? Okay. Alright. Cosine of theta over 1 plus sine of theta equals 1 minus sine of theta over cosine of theta. And somebody last period was like, can I cross multiply? I like that idea. But we don't touch the right side. I get that probably cross multiplying would be the easiest thing. We're not touching the right side. Oh, by the way, FYI, do we have to write cosine squared x every single time? I am okay with you just writing an arrow and writing it the last time, if that's what you want to do. Okay? So like on this one, are you going to want to write 1 minus sine of theta over cosine of theta every time? Nope. But you need to have your equal signs, and then at the end, just add the arrow. All right. What should I do? This one's, we haven't had one like this at all. Anybody want to guess how to get this? Square it. I like that idea, but I cannot just square it. Because if I square this, it would give me 1 plus 2 sine of theta plus sine squared. It wouldn't help me. But multiply by what? The conjugate. Do y'all remember what a conjugate is? So you are on the right path. What is a conjugate?
1 minus sine.
And somebody during first period made a comment. They go, the conjugate is basically like rationalizing for this. College algebra is helping y'all out right now. We are going to multiply by the conjugate. Why am I multiplying by the conjugate? Because up top, I'm going to leave this 1 minus sine of theta, cosine of theta, over, what does the bottom turn into when I multiply these out?
1 minus sine squared theta.
1 minus sine squared theta. It creates that difference of 2 squares. And then again, I'm just going to do an equal sign with an arrow. Well, anything look familiar there? That 1 minus sine squared theta is a, almost always if you have a 1 plus or minus something squared, you're probably doing an identity. What is 1 minus sine squared theta going to be? Cosine squared theta. And what do I know? The cosines cancel, and I'm left with and hey, what does this equal? We're done. We got our answer on the right hand side. We don't need to go any further. Okay, what part are we lost? Okay, the very first part is probably where we're lost. The whole unit? Okay, but let me ask, do you know what I did right here? Do you understand what I did as far as the conjugate?
Oh yeah, I just don't have
The identities memorized? We're going to get there. So honestly, with this, like especially like these right here, it's just going to be practice. So today's the last new thing you're learning. Tomorrow, you're doing homework. Thursday, we're going to practice this more. Friday, we're going to practice this more. Monday, we're practicing more. So it's just going to take doing it over and over again for you to get used to it. 100%. All right, the last example, I'm going to let you, should I let you start it or do you? Oh, we have time. I'll do it with you. I got to turn it over. Did y'all write all that down or not yet?
I just need to answer.
Okay. You need the whole page? Is that what she just said? What have you been doing?
No, because I gave up. Because she didn't like how my notes were written.
Holy cottage cheese.
Ooh.
She didn't mad.
Her notes?
They literally do mad. I just don't have the right hand side of the yes, they did mad.
Oh, just draw an arrow. The right hand side? I'll show you in just a minute. Y'all can, yeah. Alright, last one. Everybody with me? Everybody do this last one together. Example 4. This one, actually these last two are test questions. So the one we just did and the one we're about to do are test questions. Straight up. This is like one we've already done. What should we do here? common denominator. So you could do the conjugate and you could approach this a completely different way. There's multiple ways to do these. I'm going to do common denominator because, yeah, in my opinion, it's easier. So what am I going to multiply this side by? Sine of theta. And on your test, I want you to show that step. I'll count off points if you're not showing every step. Because sometimes y'all just get bam things, and I'm like, where did that come from? What am I multiplying this side by? 1 plus cosine of theta. And I'm just going to write an equal sign, and remember, we just have to do that arrow. Let's talk about math real quick. If I gave you x plus 1 times x plus 1, do you agree it is not x squared plus 1?
Yes.
Are you sure you agree with that?
Yes.
What do I got to do? I got to FOIL. What is x times x? X times 1. X times 1 and 1. Do y'all agree you have to FOIL it out? Double distribute, whatever you called it. So do you agree that gives me x squared plus 2x plus 1? Do you know how many times y'all tell me it's this? You look at me like that, but... Okay. Now let's go to this one. Same situation. What is 1 plus cosine times 1 plus cosine? It is not 1 plus cosine squared theta. 1 plus 2 cosine theta plus cosine squared theta. Let me give y'all a minute to write that down. Maybe not a full minute. And if it's written down, I want you to think about what would you do next? There is no cottage cheese in this problem. Yes. Yeah, it should say plus. Thank you so much. Appreciate that. Okay, Gabriel, do you want to announce to the class what you would do next in this situation? Gabriel, announce it. Yeah. Even though they're not next to each other, do you agree I have cosine squared theta and sine squared theta? And do you agree that's an identity?
Yep.
What does that equal? 1. So this is going to be 1 plus 1 plus 2 cosine of theta over and guess what we're going to do next? What's 1 plus 1?
2.
Now, honestly, I would be fine with you doing that in one step. I am not, because it's your notes and I want you to see a thorough explanation of this. And then a common factor. What's my common factor here? 2. I can factor out a 2. And if I factor out a 2, what am I left with?
1 plus cosine.
Are you seeing it? And then what? They cancel. And I'm left with and if sine of theta is on the bottom, how do I move it up? Okay. Does everybody see how I went from here to here?
Is it therefore outside or inside the box?
Oh, it don't matter. Usually I put it inside the box, I think. But yeah, it's okay if it's outside. All right, here is the whole problem. I have like 5 more I could, I'm not, but I have like 5 more I could give you to do. We are going to practice some of those later this week so y'all can get more comfortable with them. What questions do I have about this last step right here? Nicole, you were looking at me like I was absolutely crazy. Okay. I think you looked away right here. Do you see how I canceled those out? Okay. And do you see how I'm left with 2 sine? And if sine is on the bottom, what's the reciprocal of sine? So like you could technically do an extra step right here and then do 2 times 1 times. Like you could technically put that step in between these so that you knew that it was 2. Oh, that's wrong. If you write 2 over sine, that's right. 2 over sine like that? I did that wrong just now. If you, like, you could add an extra step right here is what I'm saying. I didn't, but you could. No, if you wrote it like this, that's right. Oh, no. Your answer has to be, what does it equal at the top right here? Oh, no, keep going. Like if it was simplifying, not verifying. Keep going. Yeah. All right. Y'all can start working on your homework. Your homework, I do not want you to do on that half sheet. Please get out a sheet of notebook paper and do it on the notebook paper.